name's Cherisa, and I'm an engineer here at Agilent Technologies. Today, I'll be demonstrating how you can overcome the challenge of making accurate modulation quality measurements on 802.11ac transmitters and their components with Agilent's MXA signal analyzer. If you're developing transmitters compliant with 802.11ac wireless LAN standard, you know that using 160 MHz channel bandwidths and high-density modulation of 256 QAM demands high-quality signal modulation. Agilent was the first to market with 160 MHz bandwidth analysis capability for 802.11ac signals with our high-performance PXA signal analyzer. Today, I'll be demonstrating our mid-range MXA signal analyzer, which now offers 85, 125, and 160 MHz analysis bandwidth options, providing the performance you need for characterizing your 802.11ac transmitters and components at a lower cost. You will quickly see that with an EVM of approximately 0.45% and 160 MHz of bandwidth, the MXA is ideal for testing your 802.11ac transmitters. To perform this measurement, I've used the Signal Studio wireless LAN software to create the 802.11ac 160 MHz waveform, and I've stored this waveform in the MXG vector signal generator. The MXG is now generating the RF signal that's feeding into the MXA, which also has the 160 MHz analysis bandwidth option. Now let's take a look at the demodulation quality using our 89600 VSA software. You can see the full 160 MHz channel centered at 5.25 GHz on the spectrum display. Also, we can see the 256 QAM constellation as a result of the demodulation. It's important to understand your equalizer training analysis settings when making EVM measurements and comparing between test systems. The 802.11ac standard indicates that for testing the EVM of a wireless LAN transmitter, the equalization should be performed over the preamble only. When we use the preamble only setting for the equalizer training in the VSA software, the OFDM error vector summary shows an impressive EVM of approximately 0.45%. For applications like power amplifier tests, the equalizer training can be set to preamble pilots and data to test to a better level of performance. We see an improvement because when the equalizer uses the preamble only, the equalizer estimate contains noise from the preamble, which adds to the measured EVM. With the equalizer setting of preamble pilots and data, the equalizer estimate is averaged over all of the symbols in the measurement, which produces a more accurate or less noisy channel and improves the EVM performance. With this analysis setting, we are now showing approximately 0.3% EVM, which is over 2 times better than other vendors' claims with their mid-performance analyzers. This EVM performance ensures that the MXA can help you accurately characterize or verify the performance of your 802.11ac transmitter designs. I hope that you have enjoyed this brief demonstration showing the MXA signal analyzer's best-in-class demodulation quality of a 160 MHz 802.11ac wireless LAN signal. To learn more about Agilent's MXA and see how it can help you accelerate your next-generation wireless testing, please visit the URL shown on the screen below. Thanks for watching.